What if you fell into a black hole? Black holes are terrifying cosmic monsters. They're invisible, unstoppable, and weird enough to make even physicists sweat. Let's say you're an astronaut, brave, curious, maybe a little reckless, and you decide to jump feet first into a black hole. Good news first, you won't feel anything, at least not right away. Bad news, you're about to be stretched like spaghetti, fried by radiation, frozen in time, and ultimately erased. Let's break it down. There are different kinds of black holes. Some are small, like the ones formed from collapsing stars, maybe 10 to 100 times the mass of our sun. Others are supermassive, like the one at the center of our galaxy, Sagittarius A, which is about 4 million times more massive than the sun. This matters, because in small black holes, the gravitational pull gets extreme very quickly. If you fall into a small one, you'll get shredded long before you even reach the center. But with a supermassive black hole, something strange happens. You could cross the point of no return, the event horizon, and feel nothing. No sudden pull, no pain, no spaghetti limbs. Not yet. But that's the beginning of the end. As you get closer to the center, gravity starts acting weird. Imagine you're falling feet first. Gravity is pulling harder on your feet than your head because they're slightly closer to the center. That difference in pull stretches your body out while compressing you from the sides. This effect has a charming name, spaghettification. At first, the difference is tiny, but it grows exponentially as you fall. Your body is pulled into a long, thin strand of atoms. Eventually, even your atoms are torn apart. In a small black hole, this happens before you cross the event horizon. In a supermassive one, it happens after, which is worse because you can't escape or even warn anyone once you're inside. To an outside observer watching you fall in, something strange happens. From their point of view, you never actually fall in. Instead, you appear to slow down as you approach the event horizon, moving slower and slower, until you freeze in place, like a paused video. Why? Because gravity warps space and time. Near a black hole, time stretches out. This is called gravitational time dilation, a prediction from Einstein's general relativity. So while you feel like you're falling normally, the outside universe sees you moving in slow motion, your image redshifting into darkness. Eventually, you fade away completely. Not because you're gone, but because light can't escape the black hole to show you anymore. Black holes aren't empty. The area near the event horizon is surrounded by a swirling disk of matter, gas, dust, sometimes whole stars, called the accretion disk. This disk gets heated to millions of degrees. It emits X-rays and gamma rays, the kind that can fry spacecraft or, say, astronauts. So unless you somehow avoid the accretion disk and jump in cleanly, you're likely to get roasted before you ever reach the horizon. Even if you dodge the radiation, you're not escaping what's next. The center of a black hole is called the singularity. It's where all the mass is concentrated into a single point of infinite density. No one knows what it's really like, because the laws of physics break down there, space and time collapse, our math gives up, and if you reach it, so do you. There's no way back, no communication, and no physical structure that can survive it. Even your information, the quantum state of your particles, might be destroyed. Some physicists argue that information is preserved thanks to Hawking radiation or other theoretical mechanisms, but either way, you're gone. So the question remains, do you really die? Well, that depends on your definition of you. From your perspective, you fall in normally and die at the singularity. From the universe's perspective, you freeze at the event horizon forever. Your atoms, torn apart. Your signals, lost. Your memory, wiped. Your dignity, hard to say. But the weirdest part? You wouldn't even know you died. You just fall and stretch and fade. So, what if you fell into a black hole? You'd experience the most extreme physics the universe has to offer. Stretching, melting, time distortion, and total annihilation. And you'd be the coolest pasta noodle in the galaxy. Just maybe don't try it.